Okay, today you're going to get a chance to catch up on yesterday's classwork. The effort on some of these was not great, so we're going to fill in blanks and make sure we get all of our class points and that we learn something in the process. So we talked about negative numbers yesterday. All negative numbers are left of 0 on the number line. Make sure you're filling this in if you don't have it. Negative integers are not only left of 0, but if they have a movement, they move you left on a horizontal number line, and they move you down on a vertical number line. We would use negatives if we owe people money. If you moved backwards on a football field, if the temperature was going down, all of those things are negative numbers or negative integers. Positive integers are the opposite of that. They're right of 0 on a number line. If they show movement, they're moving to the right on a horizontal number line, and they're moving you up on a vertical number line. We would use these for gaining money, for temperatures going up, moving forward on a football field. Positive numbers are usually a positive thing in our lives, and negative numbers a lot of the time are a negative thing, costing us money, losing money, things like that. Both are valuable. We're going to use both a lot. On our next page, the directions say use the number line below to practice counting up and down. A lot of us were struggling yesterday. We want to get our work done so fast that we're not reading the directions. So we really want to make sure we're taking time to read the directions and not only get our work done, but that we are actually using our work to better our math skills. So if we look right here, it says counting up, starting at 0, corresponds to what? Well, we just talked about it. If you're counting up, that's going to indicate positive numbers. Going up is going to indicate positive numbers. And likewise on this section, it says counting down, starting at 0, corresponds to, well, if we look back to the front page, we said when you count down, that is corresponding to negative numbers. So a couple of things that are pretty simple, but we need to know those going into 7th grade math. Okay. Here they've provided us with a number line, and we're going to do parts A, B, and C. So part A says, where do you begin when locating a number on a number line? You're always going to begin at 0. Now, movement is going to occur. You're going to move left and right, but every time you start, you want to start right here on 0. Again, anywhere I'm filling in answers, you want to make sure you're filling them in too, and we'll have a short discussion when this video is over so that you all can make sure you understand everything before we move on to the next section. Part B says, what do you call the distance between a number and 0 on the number line? Now, we watched a video yesterday, a short little video, and we heard a term called absolute value. And that's exactly what this is about. So if you pick a number on the number line, doesn't matter which one, we'll pick 0. And over here, we'll say this is 1, 2, 3, 4, 5. The space between these two numbers, it's a distance. It is called absolute value. Same thing happens over here. If we go -5, there is also an absolute value between 0 and 5. It's just a distance. So what do you call the distance between 0 and a number? It's called absolute value. That's what you need to have written down. Vocabulary term that you will definitely need throughout the school year. Moving on, what is the relationship between 7 and -7? Well, 7 plus negative 7 we talked about yesterday equals 0. Anytime you have a number and its opposite, here another example would be 8 and negative 8, 12 and negative 12, 1,000 and negative 1,000. Anytime you have two numbers that are opposites, like 7 and negative 7, they are called additive inverses. Moving along to the next page. So this is page 3. The directions say, what is the sum of the card values shown? So in some classes we played the integer game yesterday, and in some classes we didn't. It's a pretty simple game which you draw 5 cards. Positive numbers move you to the right. So positive numbers are going to move us to the right. Negative numbers are going to move us to the left. So we've got 4 cards here, 1, 2, 3, 4. And we're just going to go through and see where these numbers would move us on this number line and where we would end up. So if we look at the first card, remember you're always starting at 0. The first card here is 5. 5 is a positive number, which means it's going to move us to the right 5 spots. 1, 2, 3, 4, 5. For the next card, we're not going to start at 0 because we've already moved. I'm going to switch colors here. The next card is negative 5. And if you've been paying attention, those two numbers are additive inverses. So negative 5 is a negative number. It's going to move us back to the left. 1, 2, 3, 4, 5. So when you get really good at this, you're going to realize we kind of wasted our time with those two, because since they're additive inverses, you end up going right back to where you started. So we're at 0 again. The next card is negative 4. Remember, negatives move us to the left. So we're going to go 1, 2, 3, 4 spaces left. And our last card is 8. It's positive 8. It's going to move us to the right. So we're here right now at negative 4. And here we go 8 spaces to the right. 1, 2, 3, 4, 5, 6, 7, 8. So we moved 8 spaces to the right, and we end up here at positive 4. Now this card does not mean move to the 8. It means move 8 spaces to the right. So if we clean up all this mess, at the very end we ended up being right here at positive 4. So if we look to question A, it says what is the final position on the number line? We end up being at 4. Question B says what card or combination of cards, so you could pick 1, 2, 3, 4 different cards, would you need to get back to 0? Well, the easiest way to do that would find the additive inverse. We're at 4 right now. We need to get here to 0. Easiest way to do that would be with negative 4. So that can be your answer. Another way to do it, if you wanted 2 cards, you could do negative 2 and then negative 2. And there's several other options. But the easiest way would be negative 4. Exercise 2. This is the additive inverse, so we're going to be dealing with that vocabulary term again. It says use the number line to answer each of the following questions. Part A, how far is 7 from 0 and in which direction? So if we find 0 and we find 7, we have a 2-part question. First of all, how far is 7? Well, it is 7 units away. We could prove that. 1, 2, 3, 4, 5, 6, 7. And it says in which direction. And so it would be 7 units to the right. And why is it to the right? Because 7 is a positive integer, and positive integers are always to the right. Part B, what is the opposite of 7? In other words, if we had 7, how could we make it 0? So again, that's additive inverse. Think about it. How could we move from here back to here? That's the opposite of 7. Answer would be negative 7. Part C, how far is -7 from 0 and in which direction? Well, that's the opposite, right? Since 7 and -7 are additive inverses, they're both the same distance from 0. So again, it would be 7 units away, even though it's in a negative direction. And because it's in a negative direction, it would be 7 units, not to the right, but to the left. But remember, since it is a distance, it is a positive number, even though we would be moving left of the number line. Part D says, think back to our previous work and explain how you would use the counting on method to represent the following. While playing the integer game, the first card selected is a 7. Basically, they just want you to explain, if you drew a 7, what would you do? And since 7 is positive, you would move right 7 spaces. Okay? The next thing they're saying, and then the second card selected is -7. Well, if the second card selected was -7, that would mean you're going to move which direction? You're going to move left 7 spaces. The shortcut would be recognizing that these two numbers are additive inverses, and then you wouldn't have to do any movement at all because you know they would equal 0. So it would save you a whole lot of time not to move them at all. And by talking you through that, I actually answered part E. It says, what does this tell us about the sum of 7 and its opposite? Well, 7 and its opposite are additive inverses, so their sum, or what happens when you add them together, they equal 0. They equal 0, or they equal no movement. 2 questions left. Part F says, look at the curved arrows you drew for 7 and -7. What relationship exists between these two arrows that would support your claim about the sum of 7 and -7? Well, we didn't draw any yet, so I'm going to real quick draw a number line. 1, 2, 3, 4, 5, 6, 7. And so they want to see the movement here. So if you started at 0 and you moved 7 spaces to the right because our integer was 7, and then you turn around and you move 7 spaces back to the left because the second integer is -7, you're basically just undoing everything you already did. So that is supporting our claim because they're equal to 0, and that movement that we're doing is really unnecessary. But they're asking us to prove it and talk about it, and that's what we're doing right there. Last question, do you think this will hold true for the sum of any number and their opposite, and why? And we talked about it yesterday. Any number and their opposite is always going to equal 0. And our proof of that was the definition of additive inverses, that additive inverses always equal 0. We could make a number line up here that goes all the way to 1,000, and we could move 1,000 positive and 1,000 back negative. Those additive inverses always equal 0. So at this point, we should have our classwork from yesterday completely filled out. Everybody should be getting full points, and I want you to take just a minute and think about all these questions and anything you might have, anything you might be wanting clarification on.